Okay, here is a second example for the homework on page 632. Now let's try this one. Let's say we're still going to write the equation of the parabola, right there, and we're still graphing it, right? So now, but in this case, let's say we're given this information. Let's say we know that the focus is at 2, 4, and we know that the the directrix is going to be at x, so here's the directrix, is at x equal to -4. Now again, we want to write the equation, and we'll do that first, and then we're going to graph it. Well, to get a good idea of how to do that, again, let's go ahead and sketch the information to start. And so let's make a bit of a, let's start by making our graph over here, right? And then the focus is at over 2, up 4, so right there is the focus, right? 1, 2, 3, 4, right? And then the directrix is at x equals -4, so 1, 2, 3, 4. So the directrix is a vertical line at x equals -4. Now, we know, because of the rules of parabolas, that the vertex point, which we need in order to write the equation, is going to be halfway between those 2 points, on a line halfway between them. Well, we can see it's 1, 2, 3, 4, 5, 6 units over, so the vertex has got it between the focus and the directrix, so the vertex has to be 3 units over, 1, 2, 3. So the directrix, the vertex, has to be right there. Okay, and we can see that the coordinates of that point are -1, 4. So the vertex, we'll write this here, has to be at -1, 4. Okay, so what do we do now? Well, we see now that since the directrix is vertical, that the parabola has to be horizontal. And if the vertex is here, and if the focus is over here, we can see that our parabola is going to be curling to the right around it, so it's going to be opening to the right. So we're going to use this equation right here, since it's horizontally oriented. X minus h is equal to a times y minus k quantity squared. The h always goes with the x, the y always goes with the k. Now, so we can see that the vertex is -1, 4, so the h is -1 and the k is 4, so it's going to be x minus -1 is equal to a times y minus 4 quantity squared. Now we just need to figure out what the a value is. Well, we see that the focal distance is from the directrix to the focus is, or to the vertex, is 3. From the focus to the vertex, also 3. And so that's going to tell us that the focal distance is 3. So we use our handy-dandy formula. A is equal to 1 over 4 times 3, 1 over 4c, so A is equal to 1/12. So we've got x plus 1 is equal to 1/12 times y minus 4 quantity squared. Now in order to make it look nice and neat, we'll subtract the 1 from both sides and get x is equal to 1/12 times y minus 4 quantity squared minus 1. And actually we're subtracting 1 from both sides, aren't we? Okay, so anyway, so there is the equation we're looking for. Now we graph it. We've already got the vertex. Now we just need a couple of other points. Now, since this is a horizontally oriented parabola, when we make the t-table, we're going to pick y numbers to plug in to get the corresponding x. So, and we're going to pick convenient ones that are around where the vertex is. So the vertex y number is there at 4, right there. And so I'm going to pick, say, 2 and 3. Y equals 2 and y equals 3 to go in. So here's 2 and then there's going to be 3. So I plug the 2 in. Okay, so that's going to be 1/12 times 2 minus 4 quantity squared, oopsie, minus 1, right? So that's -2 squared is going to give us 4. So it's going to be 1/12 times 4, parentheses, minus 1. So that's 1/12 times 4 is 4/12. That's 1/3 minus 1, -2/3. Okay, now 3. So our ordered pair there is therefore going to be x equals -2/3, and then y is going to be 2. So there's our ordered pair. Now we put 3 in, so that's 1/12 times 3 minus 4, quantity squared minus 1. That's 3 minus 4, that's -1 squared is 1, right? So that's going to be 1/12 times 1, so that's going to be 1/12 minus 1, which is 11/12, right? So our ordered pair here is going to be, or rather, -11/12. So our ordered pair is going to be -11/12, 3. So we go ahead and graph that over here. Okay, so -11/12 3 is about here. And -2/3, 2 is about here, right? And then using symmetry around over the axis of symmetry, since it's horizontally oriented, we reflect those up. And we're going to have a point up here, and another point up there. And here is our parabola, something like that. Okay, so there is our graph right here, and then here is the equation over there. Anyway, okay, so I'm going to do one more example after this one, part C. Thank you.